Welcome to Chemistry A to Z, back-to-back dose of chemistry.
Please subscribe, like, share, and comment. Welcome, and our topic for today is balancing of chemical equations. A chemical reaction is a process whereby one or more substances are converted to an entirely different substance or substances that are different from the starting material. The starting material or materials are known as reactants, while the substance or substances formed are called products. A chemical reaction can be of any form as shown on the screen. Chemical reactions are illustrated using chemical equations. A chemical equation is a statement in form of symbols and formulas that gives the identities and quantities of all the species involved in a chemical or physical change. On the left-hand side of the equation are the identities and quantities of the species present before reaction, and on the right-hand side are the identities and quantities of species present afterward. Both sides are separated by either a single or double arrow to show a forward reaction or an equilibrium reaction respectively. 1. Determine the number of atoms of same element on both sides of the chemical equation. 2. Balance the equation by applying the law of conservation of mass to get same number of atoms of every element on each side of the equation. Chemical formulas are balanced by placing the right coefficient in front of them. In this example, we have zinc reacting with hydrochloric acid to form zinc chloride and hydrogen gas. So, we have one zinc atom on the left hand side and one zinc atom on the right hand side. So, zinc is balanced. We have one hydrogen atom on the left hand side and two hydrogen atoms on the right hand side. So we need to balance the hydrogen here. So by adding a coefficient of 2 to make the number of hydrogen on the left hand side to be equal to the number of hydrogen on the right hand side. Also on the left hand side we have one chlorine atom, but on the right hand side we have two chlorine atoms. So we need to add 2 to this side. So to balance this equation, I can simply just add what? A coefficient of 2 here. So by doing that, the number of atoms on the left hand side equal to the number of atoms on the right hand side. So we have one zinc atom here, one zinc atom here. We have two hydrogen atoms here. That's this coefficient of 2 multiplied by this one hydrogen atom will give you two hydrogen atoms, and we also have two hydrogen atoms here. We have two chlorine atoms on the right hand side, and this coefficient also belongs to what? This chlorine atom. So the coefficient of 2 here does not only belong to the hydrogen, but it belongs to hydrogen and this chlorine atom. 3. Subscript G, S, L, and AQ are used to indicate gaseous, solid, liquid, and aqueous reactant or product respectively. This point is optional. 1. You cannot change a subscript. If you do this, this equation becomes balanced, but you have changed the substance from water to hydrogen peroxide. 2.
You cannot place a coefficient in the middle of a formula. The coefficient should only be placed at the beginning of the formula, not in the middle.
For the first example, on the left hand side, we have one potassium here, we have one potassium here, we have one chlorine here, we have one chlorine here, then we have three oxygen atoms here, we have two oxygen atoms here. So we have to look forward a way of making the number of oxygen atoms on the left hand side to be equal to the number of oxygen on the right hand side. And we can simply do that by multiplying by multiplying 3 by the number of oxygens here and multiplying 2 by the number of oxygens here. So we have 2 here to make it 6. We have 3 here to make it 6. So now if you look at it again, our potassium is now 2 on the left hand side and 1 on the right hand side. So we have to add 2 here, making it what? 2 potassium on the left hand side, 2 potassium on the right hand side, 2 chlorine atoms on the left hand side, 2 chlorine atoms on the right hand side. Take note, these two belongs to potassium, chlorine and oxygen. These two belongs to potassium and chlorine. So on the left hand side we have 2 times 3 making 6 oxygen. On the right hand side we also have 3 times 2 making 6 oxygen. So this is balanced. Now for the second example, we have 2 carbon atoms on the left hand side, we have 1 on the right hand side, 4 oxygen on the left hand side, we have 2 on the right hand side, then we have 3 oxygen atoms here, we have 2 plus 1 making 3 on the right hand side. So let's start with the carbon. For the carbon atom, we have 2 atoms here, we have 1 atom here, so we add 2 to this side making it 2 2. Then the next element is hydrogen. We have 4 on this side, we have 2 on this side, so we add 2 to this side making it what? Making it 4 on this side, then 2 times 2 making it 4 on this side as well. Then the next atom that we'll look at is what? Is oxygen. We have 3 on this side, then we have 2 times 2 making 4, then 2 times 1 2, so 4 on this side, then 2 on this side making 6. Overall we have 6 oxygen atoms on the right hand side and we have 3 on the left hand side, so we can add 2 to this side, so making it 2 times 3 6 oxygen atoms, 2 times 2 4 plus 2 6 on this side. So the equations are now balanced. In this example, we have 3 carbons on the left hand side and we have just 1 carbon on the right hand side. So we can simply add 3 to this side to make it 3 carbon on both sides. So here we have 6 hydrogen here on the left hand side and we have 2 hydrogen on the right hand side. So we have to multiply these 2 by 3 to make it 6, just like this one. So we add 3 here making 6. So on this side we have 2 oxygen on this side, that's on the left hand side, but on the right hand side we have 3 times 2 6 and 3 times 1 3, so 6 plus 3 making 9. So we have 9 oxygens on the right hand side and we have 2 oxygens on the left hand side. So we have to multiply these 2 by 4.5. That's 4.5 multiplied by 2 will give us 9. So we can either put 4.5 or 9 over 2. So let's use 9 over 2. So you can leave your answer like this, but it is better to make it what? Whole numbers. So what you can do is what? You can multiply this denominator 2 by this side, by this side and this side. So in that case now, you have 2 C3H6 plus, so when you multiply 2 by this side, it becomes 9. So you have 9O2 to give 3 times 2, that would be what? 6 CO2 plus 3 times 2, 6 H2O. So if you look properly, you can see that we have 6 carbons here, we have 6 carbons here, we have 2 times 6 hydrogens, 12 hydrogens here, we have 6 times 2 hydrogen, making 12 hydrogens on this side. Then we have 9 times 2, making 18 oxygens here. We have 6 times 2, that's 12, 6 times 1, that's 6, 6 plus 12, that's 18. So we have 18 oxygen on this side and 18 oxygen on this side. So for the second example, we have 1 calcium here, we have 1 calcium here, we have 2 times 1 oxygen, that's 2 oxygen on this side, we have 1 oxygen on this side. So we add our 2 here, our coefficient 2 here. So on this side now we have 2 times 1, that's 2 hydrogen plus 1, making 3 hydrogens here, and we have 4 here. So we can multiply this side by 2. So we have 2 and 2, making 4. So when you do that, multiply your 2 here, so you have 2 hydrogens here and 2 hydrogens here, making 4 hydrogens, and that is what you have here, 4 hydrogens. So you have 2 chlorines here, and you have 2 times 1, 2 chlorines. So the equation is balanced.
Finally, in balancing a chemical equation, the smallest possible whole number coefficient should be used. Thank you for watching this video. See you in the next video.